simultaneous equations. So, I want to talk about first is simultaneous equations is one of those things where I think I said to you yesterday about there are kind of methods for solving and people just get told this is how you solve them. I don't really understand what it is they're doing, and therefore some of the methods that could easily be linked and put together are not understood and therefore not used when they could be. So my question is for you, well, what are simultaneous equations? What do they mean? Yes?
When there's a variable on either side?
I would say that doesn't explain to me what a simultaneous equation is. Yeah.
Well, there's two or more variables at the same time.
Again, what does that mean? There's two or more variables at the same time. Can anyone give me... Oh, what are you going to say? We're just scratching.
Yeah.
Alright, can anyone give me... Well, probably not off the top of your head. So, let me just write one thing. So if I said 2x's plus 1y is equal to, what should I do? 10. Okay. So, first start. That is the form of the equation that you will normally see for a simultaneous equations question. Right? This could be written in a different way, and if I were to write it in a different way, that might change your whole thought about what it is we're doing. Might. So I could rewrite this as y equals 10 minus 2x. Alright, same thing, exactly the same. Do you see that?
Yeah.
Alright. But this one on this side, how would you explain, what do you know about that one, 10 minus 2x? What would you tell me? Anything? Yeah?
It's the inverse operation of that.
No, it's not. It's exactly the same operation.
It's like making y the subject.
Okay, so it's made y the subject. I've got it y equals. Anything else you can tell me about it? What is it?
An equation.
An equation.
Simultaneous equation.
No, it's not yet. I think. You shouldn't be. You should already have it, but hurry up. Okay. It's not a simultaneous equation. The reason why it's not a simultaneous equation is because it's the same equation written twice, but just rearranged. It's exactly the same equation. But if I look at the one on the right hand side, are you not recognising it as sort of y equals mx plus c stuff, the straight lines?
Mm-hmm. What?
Because 10 was our original subject, so it's the highest number. No?
What? Alright, Layla. You will want to solve.
I have rehearsal.
Right, so if we think of it as mx plus c, I'm checking the kind of knowledge you have. What does that mean? Yeah, put your agendas away and then let's get your maths books out and ready to go. 2 lessons on the phone. Megan was doing it, but at least you finished early enough. Right. What does y equals mx plus c remind you of then? Does it not tell you gradient and intercept and, you know, you not remember doing that? Year 7, 8, 9.
The graph and the run and the rise.
Rise and run and the straight line graph.
I do not remember that.
I remember that, but I don't remember.
It's a linear equation.
Yes, it's a linear equation.
Oh, I'm good at that.
Right, this is a linear equation. This is the same linear equation. Now, this is the thing. So I asked the question, again talking about with my IB1s, what is a line? So,
And 180 degrees.
so for instance, if I was going to draw the graph of this function, does anyone know kind of roughly what it's going to look like? 10 minus 2x.
Oh,
Jem?
like that. Like that.
At this angle,
So
so opposite.
going like that,
No, the other way.
the other way. So going like this.
Yeah.
Okay. Yeah.
Is it just a straight line?
So it's definitely a straight line.
A
Yeah.
horizontal?
How do I know it's going like that?
I did.
Because it's
Because-
minus.
Because it's the gradient is minus 2. Rise over run means it goes down. It's a negative gradient. How do I know it crosses up here? What would that value be? 10. Okay, so you do know stuff then. You can remember it. So this would be an example of that function. But what is the line?
Is that because it's the highest point it gets through?
No, it goes on forever.
No, I get that.
It's just where it crosses because the x value is 0.
No, I was just asking about the 10, not the line. I know what you're saying.
I'm glad you did.
Okay, never mind.
Yes.
I know this is a weird question, but for the gradient, could it be like 0 or 10, or would it just be 10 because it's on the line?
No, the gradient is minus 2.
Why would it be minus 2?
Because gradient means we've got run, which is how far right you go. And then we've got rise. And the gradient is rise divided by run. So it's how far I go up for every one I go across, or how far I go down. So in this case, every time I go 1 across, I would go down 2. So rise over run would be minus 2. So that's my gradient. If the line's steeper, every time I go across 1, I would go up or down 3 or 4, or to make the line steeper. Yes.
You asked a question.
Go on then.
So the line is like, it represents the pattern of the y.
Okay.
Because y1 would be like that, and then y2 would be the next value, and it's just, okay, I'll stop there.
No, you can explain something. Go for it. So, well, I think you sort of right. A line, said with my IB1s, is not a line. It's an infinite number of individual points. Okay? And if you have an infinite number of individual points, it would look like a line. So, for instance, what a lot of people would say is, well, 0, 10 is a coordinate, right, in this. So if I put 0 in for x, minus 2 times 0 is 0, plus the 10 makes 10. That's why I've got a point. The next one they would say is, if I put 1 in, what will come out? So 10 minus
1.
2 times 1 is...
2.
Minus
So 10 minus 2 is 8. So this point would be 1, 8. And I would have another point at 2, what? 6.
I don't really get it all. Sorry, I just don't
It's just
see
kind of
why
it's gonna be on our test.
That's not.
Don't ask me about tests, because then all you're focusing on is, I'm only going to listen if you tell me it's directly on a test. It's knowledge, right? I'm perfectly happy if you say I don't understand this, but we need to... The trouble is, what I want to do with simultaneous equations, if you don't understand this, we need to go and get it sorted out. Okay, that's it.
Okay,
Yes.
just a quick question. So the 8 and the 6 are 2, and the 8 and 10 and the 6. The 8 and 10 are 2 apart, and the 8 and 6 are 2 apart. But the 6 and the 0 have a smaller space.
Oh, it's a sketch. It's
It's
just
not
a rough
to scale,
sketch,
it's not
isn't it? No,
like-
it's not to scale. I mean, you saw me just draw rough lines
I
and...
wasn't sure if it was like
Like
that
it's-
wasn't.
No, so you can see, I mean, really what I would have to do if I was going to keep this going is I'd have to rub out that line, wouldn't I, and put it much lower down here.
Okay.
Yeah? So the next point would be at
4.
4, 3, yeah? The next point would be at 2, 4. Yeah, or 4, 2. That way round. Yeah, Ali.
Two things. First of all, I'm just wondering if you got the email I sent you about the questions. And also, how do you know the bottom line? Does it already come just like with the numbers?
What number, and then what can you help?
Well, these are my x values that I would put into this, yeah?
So when you get the graph, it'll already have the numbers on the x-axis. What? And how do you know which ones to put?
I get it now.
Because on the bottom.
Right, we're going to really have to go back to basics if people are not getting functions stuff, like just linear equations. We really have to go. So
The numbers on the x-axis is like getting replaced is the x, like 4 equals x.
yeah, but I think the question is like if excuse me if I get it wrong. If I'm looking at let's do a really basic one. If I wanted to draw the graph of the function 3x plus 2, how do I do it? All right. Well, what I do, I'm going to introduce a few different words. So I decide the domain of the function. All right. The domain of the function are the x values that I'm going to use. All right. The range of the function are the y values that will happen because I've put the x values into that equation. Yeah? So, I decide the domain. So, I'm sure you'll remember doing, here's a table. Alright? The x values are what I decide. Which x value would you like to put in?
Y, 1, 2, 3, 4, 5.
Why 1, 2, 3, 4?
Because that's the first 4 numbers.
No, it's not.
On the positive side.
No, it's not. See, this is the thing. Your reaction to that does not show one of, okay, what do you mean then? That sounds interesting. It's you're not listening to me then. Stroppy head drop round, right? What is the first positive number?
0.0 something.
Okay, we can't actually say the first positive number. Thank you for your wisdom there. You're very correct. Why do we put this is but quite a lot of you are giggling away here at the moment, but the trouble is you're giggling away at sort of sounding like harsh, you're giggling away at your ignorance. I'm trying to help you with something that you're supposed to know at this stage. You are supposed to know this. So we're trying to fill these gaps. And I'm trying to give you this knowledge. So you need to maybe focus a bit more. Otherwise things are going to continue to be hard. So I asked why you would do 1, 2, 3, 4. I'm not saying that's the wrong thing to do, but your answer for why it being the first number is incorrect, and that also leads to a misconception about what the line is. So why would you choose 1, 2, 3, 4?
They're the first whole numbers.
They're not first. Alright, okay. But what about negatives? Are they not whole numbers?
Positive, the first positive.
Okay, and what has that got to do with anything?
They're just easiest to
Okay, I'd go with easy. Right? I'll go with they're the easiest ones. Alright? They're not the first necessarily of anything. They're the easy one. If you just said easy, go with you. So we pick the first, well, actually the one that we normally start with is what?
0.
0. Okay? And I put 0 in and I do 3 times 0 plus 2 and it gives me the answer 2. Which next value would you choose to do? 1. And I get the answer 3 times 1 plus 2 is 5. Okay. Okay. 2, you put it in and get 11. What? Joking, I'm glad.
7, 8.
Yeah, it's 8.
And what do you notice it goes up by?
3.
Okay. The gradient is 3. Now, what I'm trying to get at now is 0, 1 and 2. They're fine numbers to choose. They're very easy. But there are other numbers between 0 and 1 and between 1 and 2. So, if I were to draw on a graph, because this is what I need to address with you now, if I draw a set of axes and you said, where do the values come from? Well, they come from the ones I've chosen. So on my grid, I might say, I'm going to start at 0, and then I'm going to pick 1, okay, 2, 3, 4. It was my choice. I spread them out however I deem necessary, right? 0. So those are my x values, and the y values are the resulting values from those x values. Yeah, they go together. So what would I mark with a 0? 0 has a value of 2 on the y. Okay, so I would put a cross to represent the relationship between 0 and 2 in the function y equals 3x plus 2. So 0, 2, that coordinate 0, 2 represents 0 goes in, 2 comes out. Yeah. What does 1 pair with? 5. So I would put so 3, 4, 5. So 1 would pair with 5, 2 would pair with 8, and so on. And it just so happens that if I keep going, right, okay.
It's not a line, guys.
No, right, it's not a line yet.
Because like all the ones.
But if I asked this to, I think, my year 9s, I said, no, it wasn't. It was my IB. This is why it's very important that you listen at this stage. I asked my IB1s what the line is. What would you tell me the line is, Kiara?
Why? Oh, right. Infinite number of patterns.
Not patterns, no. No.
Infinite.
They just said, oh, you just draw a line between the points. You join up the points. And I said, why do you join up the points? And they looked at me blankly. I don't know. Because I draw a string.
Confuse forever. All the inventory.
Because then you can choose show infinitely.
Okay.
Show the line against it.
No.
Science, Lou.
You're all getting there.
Right. The thing is, this is not a line of best fit, because a line of best fit is what you use when you are not using a specific mathematical function that has a definite pattern. A line of best fit is when things are a bit dotted all over the place and you have a best fit to meet, right? So that comes when you collect information yourself, right? Now at the moment I've only got individual points. So this is what I want to say. What if I were to pick 0.2? What would the y value be? Yeah?
If you look on that.
Well, let's work it out. So it would be 3 times 0.2 is
3.2.
0.6 plus 2 is
0.26.
I'm so confused.
2.6. Okay, I've just put it in. So I've got, using my function, I've got 3 times 0.2 plus 2 gives me 2.6. Now, if I were to put that point in, that would be about there. All right. If I were to put 2.7, how would I work out the y value? I would do 3 times 2.7 plus 2. Okay.
Oh, so you just
8.1, I think.
go, Haley.
I could do 2.80000315.
Okay.
I'm not going to bother working out what it would be.
Okay.
This one would be a value. This one would be a value, and roughly they would be somewhere between those 2 points, and they would be on
So a
line.
a line is basically just the plates all smushed together.
Well, not squished about. That's why I said
Just
Non-whole
close.
numbers that the
There's just an
non-easy
infinite
numbers that we
numbers.
choose
Yeah.
not to work with.
yes. So this is the thing. This is where you're obviously starting to twig now. So these little dots, if I do enough of them, then they start to look like a line, yeah?
Because could you do like 2.71, 2.72, and then
Exactly.
that's why they.
And they just keep filling in every gap. You zoom in, you fill in the gaps. Now, we don't do that. What do? Well, we know, because what type of function is it? Linear. We know that all of our points will lie on a line. That perfectly straight line. So what we do is, instead of drawing all those individual points, we just draw the line. And now we've got all the points. Okay? Does that make sense now?
Yes.
So what we have then is, we then start looking at patterns. So we've got the straight line pattern. We then start going, well, how do we know how the pattern continues? Well, instead of going 0.1, 0.2, we know that if we go up in ones, the easy numbers, then it will go up in threes. All right? Here's a question for you. If it goes up in threes for every 1, what will it go up in for every 0.1?
0.3.
0.3. So that would be, you know, I could follow the pattern in whatever increment I liked. So this would be the line. Now, different functions have different patterns. So if I looked at a quadratic pattern, what would all the points end up looking like? A parabola. Well done. Parabola, yeah. Right? A cubic. So anywhere where there's an x cubed and so, what shape was that? Do you remember?
A cube.
No. An S shape, yeah? Spear's showing us. But these are the pattern that the points. So a lot of our maths will look into, can we analyse this pattern, all right, to find out our points? Can we use the shape of the curve to be able to work out these values without having to actually put everything into the function? That's what we're trying to do with our maths. Now, let's go back to what we're talking about. Now we've got a bit more. You got a question? Go on.
Yes. So you know how the linear line goes at this angle?
Yeah.
What would it be called if it went this way? So the one that we did earlier.
All right. Okay.
It's
So
still
the thing
linear,
is,
but what would-
yeah, exactly. So what we're saying is, if we have a different function, and the one we were looking at, all right. If we have a different function that's doing that,
Yeah.
it's the same idea, but instead of every time I go up an x value, so instead of doing 1, 2, 3, and it going up, it just comes
Down.
down.
Is that a
Oh, so that's what would happen if it was a minus?
Negative.
All right, you could call it a negative correlation.
We have to name
Yeah.
the different correlations, and one was like scatter.
Science.
No, it's right. Don't disassociate too much. All I would say is, right, when you talk correlations, what you're looking at is something that doesn't have, like I said before, doesn't have a direct, perfect mathematical link.
Oh, so like
So for instance, if you have a perfect correlation, you basically are dealing with a mathematical function like 3x plus 2, because the line goes exactly through every point. As soon as you start collecting your information, so whether that be speaking to people out on the street, or whether that be measuring distances of planets orbiting suns and all that kind of thing, when you can't do it exactly, the points will be slightly off for whatever reason. Therefore, when they're slightly not on a perfect straight line or a parabola, you do what's called you put a function to it, but it's a function of best fit.
And so they take only the ones that are on
So
that.
yeah, the ones that are too far away, you go, well, what's the reason for that? You do a bit of analysis. A correlation is when you start looking at the behaviour before you draw the line. So if I were to look at points that went down, they didn't all fit a perfect straight line, I would say, oh, there's a negative correlation. The relationship is negative. And that's the same. So my x and y values have a negative relationship, which means if I make x bigger, what happens to y? It gets smaller. A negative correlation. But we don't say negative correlation, because what we actually have in this case is a perfect correlation. Therefore we have a function. This function just happens to be y equals 10 minus 2x, or y equals minus 2x plus 10, yeah? So then the gradient, like we said, is minus 2, which means as the x goes up 1, the y values will drop 2. All right? The first value, because when x is 0, that means this bit's 0, so we get the 10. Yeah? So this is what I was talking about to start with. But the thing that I wanted to explain, so we're starting to get back to simultaneous equations now. So how many points can x and y be in that y equals 10 minus 2x? How many pairs are there?
Infinite.
Infinite. That's what a line is, an infinite number of points. So if I asked you to tell me, I'm thinking of one x value and one y value that I want you to tell me what I'm thinking, what would you say?
Infinite.
So I'm using this function. I have thought of one x value and one y value, okay, that go together in this function, so it'll be on that line somewhere. I said, right, tell me the x and the y value. If you get it right, you can have no homework for the next 7 years.
Doesn't mean
Well,
we're not
we're
gonna get
all
it right.
gonna get it right because there's a bunch of different.
No, you have to give me the one that I'm thinking of.
Is it
Infinite.
4?
That's not one. That's,
No, he's saying that because there's like one in
Also,
like.
you haven't written
Oh,
it
how
down,
many
so if
answers
we
did
were
we
to
get?
guess
Yeah.
it.
no, I
He's making
Or is it 4?
No, but if we guess it and we get
Yeah.
it right.
It's not right. So the thing is, like you've already told me, there's an infinite. Well, I didn't tell you if it's an integer. Even if I did, it would be an infinite number. So what I'm saying is, right, this is the thing. So I've got y equals 10 minus 2x. You now appreciate that that leaves me with an infinite number of x and y combinations, yeah? Right, I wrote it in a slightly different way. I wrote it as 2x plus y equals 10. Now the reason why I've written it like that to start with, it's the same thing, you get the same line, but it might make it a little bit easier to think. So now what I'm after is, it's not a simultaneous equation yet. You can't have a simultaneous equation. And this is the reason. What I'm saying is my x value times by 2, then I add the y value that goes with it, I will get the answer 10. How many combinations are there? Infinite, because that's just this line.
And it just keeps going.
It goes on forever. So you cannot tell me what my two numbers are for certainty. You can have a guess. You won't get it. Well, unless you're very lucky.
1.037.
No.
3,000.
That's only one number. I need an x and a y value.
Oh, and the
Now,
other one's.
so for instance, it could go on forever. Now,
Well,
do you
tell us what
understand
yours
how?
is.
Well, what I'm going to do is I'm going to explain, therefore, what the simultaneous equation things come from. So if I've got one piece of information, okay, linking two unknowns, there are an infinite number of solutions. You would not be able to tell me, right?
Unless.
So I would need to give you, because there are two unknowns, I will at a minimum need to give you how many bits of information? 2, which is where the simultaneous equations come from. So basically, I then need to enable you to do it, I would have to give you a second piece of information. Alright?
Are you going to?
Yes, I'm going to give it to you. So, let me just try and remember what number I came up with.
Write it down.
Was it
So we can know your
5 and 2?
Okay, so the next piece of information, so I'm going to make this very, very simple. So this is you might start to recognise things now. This is the first piece of information I'm giving you,
1 and a
Oh.
circle.
right? The second piece of information I'm going to give you, I'm going to really easy, is,
Y.
right,
Y.
that's 4x values, if I take the x value and the y value that go together, all right, plus the y value, well, before I write the answer, what do you know has to have happened?
I knew it.
It has to have doubled.
Yeah.
Well, not necessarily.
So the answer would be
It just has to have
increased.
It would be 12.
probably, unless x was a negative, then it might have decreased. But you know the answer's changed, yeah?
Yeah.
How do I know the answer's changed?
Because
Because I have more x's. The variable hasn't changed. I picked, and the coefficient's changed. I have more x's. I have more x's. So this time, I'm going to tell you that it is 13.
is this a number that we could guess?
Maybe.
Like if we were really lucky.
Maybe.
Will you tell us the answer?
Oh, well, you can work it out now.
Oh, okay, wait,
This should be really, really simple.
7 years to know how much you do.
So what I'm going to ask you to do, so I am not, right, just bear this in mind, I am not giving you a method to solve simultaneous equations. I have simply told you, here's one piece of information, here's another. You come up with your own method to tell me what my x and my y value are. Right, well, hang on. So,
2 times 1.
I am recording again, just so you know. So, what we have, what you're trying to do, and this is what a lot of people kind of miss the point on, what we're looking at is you are trying to look at the difference between the two on the variable side, and you're then trying to compare that to how the answer has changed. Does that make sense? All right? So I can see that the difference between the two is that I've added 2 x's. So what I might be able to do, hopefully you'll appreciate this, right? Let me know if it doesn't make quite sense. What I'm going to do is I'm going to do this, and I am going to find the difference between 2 things. How do you find the difference between 2 things? Subtract. So I am going to do equation 2 subtract equation 1. I'm finding the difference. Now you did that purely with logic by going what changed. So what happens? 4x take 2x is 2x. Y take away y is
0.
nothing. What have I just done with the y's?
Cancel. Simplify.
Use the word I just used in terms of method.
Eliminated.
I've eliminated.
So Jen.
And 13 subtract 10? 3. Right. That is the principle behind elimination method. Alright? What you are doing is you are isolating one variable so that you are trying to get it so that you can see what effect one variable has on the answer, and then you can tell me what that variable has to be.
2 minus 1.
Does that make sense?
Yeah.
All right. Yes. Yes. Okay. Do you understand then that now we would do x is 1.5, and you're all right with finding the y? Yeah.
Yeah.
Just plugging it back in. You know now. All right. Let me give you another one. I'm going to give you another.
I have any questions. Sorry.
Yeah. I'm going to go through them in a minute. I'm going to give you another one, simple one, and then I'm going to give you another one, and I want you to tell me the problem with our method that we've started with. So the one I'm going to give you, and the way I write it, you'll go, I can see already what you're going to do. All right? So I've just got to think of 2 numbers.
17.
3 and 2. 5.
Oh, I'm right.
Right, so hang on. So that will give me
5x.
okay. So that's my first statement about my x and y partnership, the ones that go together in my function. So I'm thinking 1 point. At the moment, you've only got information for an infinite number of points on a line. Yeah?
I'm confused. Can't we solve what x is?
Sorry, that should be a y.
Okay, that makes sense.
Yeah, sorry, my fault.
Oh man.
That should be a y. Okay. Let me just check that.
It's me, Manaya.
Okay, so what I'm going to do now is say, do you notice what I've not done? Okay, change the first coefficient.
Wait, where did the raw 2 go?
Okay, so
Decreasing.
How did we get to this?
So my first clue is that you can't solve it from that one, but I've now given you a second
number
piece of
3.
information about the same x and y's. Now, which variable has affected the answer?
The y.
The y.
Why?
The y has now been changed, and that has affected the answer.
Listen,
Yeah.
after I don't understand how we're finding this, can you just explain it?
Finding what?
Like, how do we figure it out?
Figure what out?
Sorry.
Like, the equation, so how are
How do you figure these one out?
Yeah.
You don't, I write them.
That's not what I mean. I mean, like, I'm having a hard time actually working this out, so like, how do I physically work them out?
But just think what has changed from one to the next.
You subtracted 2.
How many y's have I subtracted?
2.
No.
Yeah.
I've gone from plus 2 y's to subtracting a y. So what's the difference?
There's no 3 y's.
So subtracting 3 y's has done what to the answer?
Get rid of 3y.
You see it now? Yeah?
1.1.
Okay, I got 3. Why is it 3?
Because think, okay, you have 2y and you have negative y. How do you do that?
Yes, it is. Yes. No, see, what you're giving me is a shortcut that is probably will work.
The wrong way around.
Okay.
I subtracted the wrong way.
Okay, so what, yeah, okay. What we're actually doing is using this difference thing, right? Another one then.
Are you going to change both variables?
Right, have we done this? Should we go through it?
Yeah.
Right, so what we can say is then, again, elimination method is when we know what affects changing one variable. If I change both variables, is what I'll do next, you can't do it. So I've only changed one variable. The change, so for instance, I could put a line down here, all right, and I have changed what on the left-hand, the variable side. What change has happened? Ali?
The y.
I've not added a y.
Oh, you minus the y, sorry.
How many?
3.
So the change has come in the y's. And I have, as you've said, I've not changed the 3 x's, so I don't need to worry about that. Changing x, I haven't done that. This change in y on its own has changed the answer. So if I figure out what's happened, now I could do it either way round. I could start with 2 and go up to 1 if I wanted, or I can start with 1 and go down to 2. Either way. So if I work in this direction, the change, as a lot of you have spotted, is that I had to subtract how many y's? 3. I was at positive 2 y's. I ended up at negative 1 y. So the change is subtracting 3 y's. And what have I done to the answer? I have minused how much? No? The 11.5 has 3.3. Okay? The answer has gone down 3.3. Now I know what effect y had. Therefore I can work out what y is. What is y? Well, if 3 y's made a difference of 3.3, 1 y must be 1.1. Now I've got the negatives. Are you alright that I've not written the negatives?
Yeah.
Because subtracting 3 y's meant I subtracted 3.3. Therefore, y has to be 1.1. They have to be positive, right? How would I go about finding the x value now?
You would.
From any up here. Well, I don't need to do an inverse. I now know what one of them is, so I can choose. I'm going to choose number 1 and go, well, 3x's plus 2 times 1.1, because of 2y, has to equal 11.5. So 3x's plus 2.2 is 11.5. Therefore,
You inverse
3x's is 11.5 minus 2.2, which is
8.2, 9.3.
alright.
So 3.1.
1x is 3.1. So there are, my values are x is 3.1 and y is, right. Now what does that mean in terms of my graph?
It means that your graph is going to be a straight line.
But we already knew that because it's just x and y. But all that is now one particular point on each line. So how many lines do I actually draw? Because this is something else we need to go on to. How many lines have I got there? 2. Right? I've given you 2 different pieces of information. Therefore, they will be 2 different lines. But if x and y are the same in both of them, what does that mean about the lines?
They're going to be a
Diagonal.
They'll cross because they both share
Energy.
1 point. Yeah? So they both have to go through that same point. Therefore, the lines will cross.
Don't they share 2 points? The x and
Now remember, x and y is 1 point. Now this is where we will get on to solving it using graphs and using your calculator graphing it. Alright? We just find where the 2 graphs cross. It's a different way. Yes?
So, you have like your first thing, and then you have your second one, and then you do, to find the difference, you find your second one, take away the first one.
Well, it doesn't have to be, because for instance, I could have, if I wanted to, worked the other way and said it would have been a positive 3y and therefore a positive 3.3 difference if I'd gone the other way. So you can do it either way around you like, you'll get the same answer. You don't have to always do the second one, take away the first one.
So, do you, how do you,
so this will be
okay.
All I'm saying is it doesn't have to always be one way. You've got to open your mind to think, what's the most suitable way for me to do it to make it easy? I can do it any way I like. Which one would I choose?
Tell you like what was the one that was changed?
No. No, right. So, just to make it clear, the thinking about how it changes, that's my way of explaining to you how it works. Alright? They will not give you that in an exam. They will just say, solve this system of equations. Solve the simultaneous equations. And you will have to do it in whatever way. Okay? Yes?
Let's go get some water.
Okay. But I'm going to put one more. I just want, go on, do it quick. I'm going to put one more and I want you to tell me what the difference is. By the way, what we'll do, just to explain it, go.
I don't have my water bottle.
Well, go and have a mouthful of water and then come back then. If it helps. Right. What I'm going to do, because we've been through it, it's a lot of talking, a lot of listening on your part. I understand that's difficult. Some of you have resorted to jotting little flowers and things in your books now. I'm going to give you an example where this doesn't quite work and we'll go through it. Right? And we have to do something extra. We'll stop at that point. We'll go through the questions Ali's posed. And then next time we'll probably then just go, right, now you need to go through more and more examples to practice it.
After, if we have time, can we do another one that works? But like,
Okay. Well, there's plenty in your book. You could have a go, right? Now, I just want to show you. So the difference is, let's say, all right, if I said to you, I'm going to pick easier numbers this time. So I'm going to say 4x plus 2y equals 2. Okay? And then I'm going to say 3x plus 5y equals, so what would I do? Just trying to think. What have I done?
I will
12. Okay. Now, this is important to discuss because we can still use the same method, but we can't do it as it is at the moment. Tell me why.
Because both of them change.
Both of them changed. So for instance, if I were to just do my subtraction, well, if I look at the change, what is the change? So if I do it this way down, so I have subtracted an x, yeah, but I have also added 3 y's. But I do know the answer is changed by 10, plusing 10. So I can work that, I can make that statement. But now I'm in the situation I was if I only gave you the first one. I'm now in a situation where a minus x plus 3y equals 10. And how many combinations are there?
Infinite.
Infinite. You have just reduced your clues. So you've gone from having enough information to not having enough information. So we've done the same thing, but what have we not managed to do? So we've not managed to eliminate one of the variables, and I really need to eliminate one of the variables so that I can see the effect one of them is having. Because if I can isolate one of them, so, or if I change x, the answer does this, I know what x is. Yeah? I don't need to know what the first number is, I want to know what the change is, and I want to know what x changes. I don't. I know what x and y together change, so I'm no better off. So we need to think, well, what can we do? All right? So what we do, so this is no good.
Oh, so don't write this down?
Well, you can, and you can write no good. Not enough information. I don't know whether you'd want to write no good, it's like not enough information, or inappropriate. Lots of people do that when they're first starting out, and then they get lost and they don't know what to do because they've just made it worse for themselves. All right? So what we have to do is we have to use the information and we have to write some of our own clues. Although we don't know what the answers are, we can still make statements that are true. Yes?
Can you like rearrange it so that
I don't want to. I don't want to rearrange it. Rearranging isn't going to help me because that still leaves x's and y's and things. I need to do something a bit different. So what I'm going to do is I'm going to write different clues that even though I don't know what x and y are, I can still make certain statements. Okay, you had your hand up first, Matt. What are you going to say?
I don't know. I don't think it makes sense.
Doesn't make sense.
I don't think so.
No? Try it.
Well, can you multiply?
Multiply the two together.
Yeah. That would go, yeah.
No. Maybe your idea was better than what I've just said. Yeah?
Can you? Okay, but can you make x be to the make 3y be equal to 10 plus x? Then you have one of the same variable.
No, but they're the same equation. Do you remember when I started, I had to write a second equation using a different number of x's and y's, yeah? If I rearrange the same equation, I've got the same equation.
No, but like you.
No, I know what you mean. So if I wrote 3y is 10 plus x, but what's the difference between the two?
No, you make it x. But then you can put.
But what's the diff? Remember, I'm looking for the change in one of them that changes the answer.
Okay.
And do you see how by just rewriting it, there's no change? And I've not changed the answer, I've not done anything. So what I'm going to do, go on, Emma.
Why can't you multiply it?
You can. That's what I'm going to do.
Okay.
Right? I'm not going to multiply them together, but this is what I'm going to do. I'm going to although I don't know what x's and y's are, I do know certain statements. For instance, if 4x's plus 2y's equal 2, what do 20x's and 10y's equal?
Wait, what did you say? 2x's? Wait.
If 4x's, it's on the board,
2y's.
and 2y's equal 2, what do 20x's and 10y's equal?
10.
10. Why?
Yeah, because 5 and 5.
You times everything by 5.
So, exactly. I times it all by 5. Now you might go, why did I choose 5?
That's 5.
Are you happy that that red statement it's different, but it's correct?
Yeah.
Still don't know what x and y are, but it's correct. What about this one then? Well, I'm going to do the same thing. So I'm going to go this time, I'm going to write 6x's and what do you reckon? 10y's equals 24. Because this time I've multiplied this all by 2.
This is cool.
Right, I'm going to write 3 and 4. So now I've changed my information. Now I've got a situation where only one of them makes the change. Now what makes the change? So I'm going to go that way.
Why did you pick 5 again?
Because I've looked at it and gone, I can make 10y's on both of them. I could do it differently. I could have done something to make the x's the same. 12, exactly, yeah. Just want to make it to 12. I've chosen to line the y's up.
So how would I put that in the sentence as a reminder?
However comes out in
Oh,
your
so
head.
the only thing that needs to be lined up is the 10?
So what I'm doing, I pick, one of the variables needs to be the same so that I can see the effect the other one has.
So you could have tried to make the x the same.
Exactly.
Oh, okay.
Yeah? If I make the x the same, then I see what effect the y has. So it depends on which one you want to find out.
But what?
So I now know that if I go that way, so I'm going to go the opposite way to we've been doing just to show you that we can. If I go that way, I have added 14 x's, but what did I do to my answer?
Added 14.
No, I've subtracted 14 because you've got to go the same direction, yeah?
Wait,
So
where
by
did you get
adding 14 x's, so 6x plus 14x gives me 20. 24 minus 14 gives me the 10. So I know that the 14 x's equals minus 14. Therefore, 1x is
1.
minus 1. Yeah.
That's like a little circle that goes around.
That makes so much sense.
Yeah, I'm
Good. I'm glad.
Wait.
Oh, so
Why
one
did
end's
you
a minus and
out
one's
the
a...
10y?
So you want the... And then the whole thing becomes just 10.
Yeah.
Sort of.
Now, to work out x, all I need to do is I can use any of the 4 equations I now have. Any of them I like. I'm going to go back to this one. I'm going to use number 1 with x equals minus 1. So I'm going to go 4 times minus 1 plus 2y's equals 2. So that's minus 4 plus 2y equals 2. So then add the 4. So 2y equals 6, which means y equals
3.
3. Okay?
Yeah, I think
Cool.
Where did the minus 1 come from?
Up here. 14x.
Oh, right.
Yeah. Okay. Right. I want to do Ali's questions now. But we've recorded this, it's there. Right?
you just do one? Can you just write one?
Right, I tell you what we'll have to, because I want to answer Ali's questions. Right, next lesson, if any of you have emailed any questions, I'll do the same thing. But what I can do, we're going to do simultaneous equations. I can go through another couple first and then let you get on. I definitely won't spend the whole lesson, but we'll do some more before I say just get on with it. But hopefully, if you review what we've just done, your understanding will be pretty good now. Right, let's just go through these questions. So, you only asked for 10b.
Yeah.
This one, okay? So, can anyone else shed any light? Got to factorise that. Be very clear, because Ali wants to understand this. Hey.
So basically, you look at the two things and you say, what do these have in common? And you can notice that they're both squares.
Okay. They're both squares. Do you notice how automatically I'm being asked to factorise, there's certain things come into mind. I'm being asked to factorise, I've got something squared, that makes me think, and I've got a subtract, that makes me think. That makes me think it's the difference of two squares. So then I go, right, okay, well that's a squared minus, well, is this something squared? Yes, it is. It's 12 squared. And if I've got the difference of two squares, I now have to use that knowledge to factorise. It becomes?
Bracket A plus 12 bracket A minus 12.
Exactly.
And if you look at the A's, whenever you see screen, you just remember like bracket and then you can like work it.
Huh?
I know,
You got really quiet. Well,
And then do we FOIL?
if you don't see that it's a square, like you don't recognize that the number is a square number, and you see the first one has a square sign, you can just like do process of elimination and go like bracket A, then leave a space, bracket, A, leave a space. And then
So
just, like,
you said about foiling. If I foil now, what do I do?
No.
I just undo what I've just done.
Oh.
Yeah? If I expand that, I end up with a squared minus 144. So I wouldn't foil to undo that. Just to go, maybe what Hayley's saying, if we have something like 9z squared minus 69, is that the difference of two squares?
No. But that's not
9 is a
Square number.
square number. Sorry, I don't mean 69.
64.
I meant 64, yeah.
Okay.
And they're both square numbers.
They're both square numbers. So this would be what squared? 3
Z's.
z all squared minus 8 squared. So then what are the brackets? 3 plus 8.
Is that a Z?
Yeah.
Okay, and then
3z minus 8.
Because it's all in the bracket.
9z.
But if it was A squared plus 144, it would
Okay.
be A plus 12.
Right, hang on. If it's a squared plus 144,
Oh, it would just be A plus 12 squared.
No, because then you have
what doesn't that do?
12 is
It doesn't give you a subtract.
Alright, it's not subtract. It's not the difference of two squares, it's the sum of two squares, but there's no rule for that. This one doesn't factorise. This one doesn't factorise at all. Don't do anything with that.
Wait, could you write A plus 12 in brackets and then plus a little square sign?
Yeah.
Yeah, but a plus 12 squared
is A.
is a squared plus 24a plus 144.
Yeah.
You missed the middle bit, yeah?
where do we get 100? Oh, never mind.
Yeah, because I would get rid of the squared and put another. That's why when it's plus and minus, this bit becomes plus 12a minus 12a, which is why it goes. Right,
Oh, that's your final answer?
that's the final answer.
Oh.
Right, then the next one was this one. Right, so I've got 2 minutes.
I think we
I'm going to do this quick.
Wait, question.
Yeah.
Is this a simultaneous equation?
Right. No. Right, this is the awkward surds one. I'm going to do this very quickly.
Wait, this is surd.
This is on a video. Yes, it's surds. It's on a video. I'm just going to do it quickly. Sorry, you can't stop me because otherwise I won't finish it. video, you can review it afterwards and come back and ask next time if you so choose. So with this one, I've got to make that in the same form and match whatever I can. All right, and then use the equality that one side has to be the same as the other. So I'm going to expand this. So I've got 5 minus root x times 5 minus root x. I'm going to FOIL it. So I've got 25 minus 5 root x minus another 5 root x, and then plus x, because minus root x times minus root x is plus x. That simplifies to 25 minus 10 root x plus x. That, I am told, is equal to y minus 20 root 2. Now, some people would go, y is 25, but it's not yet, because 10 root x is not the same as 20 root 2. So what I need to do is adjust my 20 root 2. And I'm going to do this like the way I'm going to do it. So I'm going to say it's minus 10, because of that 10, times 2 root 2. 10 times 2 is 20. That then is y minus 10 root 4 root 2. Because 2 is root 4.
Where did the 5 and the x and the minus go?
That's expanding.
Why would you?
No, that's not gone anywhere. I'm just not writing it.
He's just waiting on that.
Sorry, that shouldn't be an equals. That should be a minus.
Okay.
Right? Right? This then, I told you I haven't got time for question. We'll have to do it next time. Then that's y minus 10 root 8. Okay? Because 4 times 2 under the root gives me the 8. Now, if I then write this back over here, 25 minus 10 root x plus x, now you'll notice that this is now 10, the same as this is. So I can now state that, okay, well, the 8 has to be the x.
Why?
Because I've got 10 root 8, 10 root 8. So now I have to write on this side, it's going to be 25 minus 10 root 8. Reason why is because if that was not 8, this 10 with this 10, it means those two would not be able to be equal, and they told me at the beginning they are equal.
What if
We'll have to talk about it next time. If you don't, keep these questions for next time. So, and I've still got another plus 8 because there's another x. Now, 33 minus 10 root 8 is y minus 10 root 8. Therefore, y is 33. So I know x is 8, y is 33. Okay? I'll put the video on YouTube, on the blog, on the Firefly. Watch it, review it. If you want to ask us again next time, we can do it.
should we have to
Email me. If all of you want it, get one of you to email me.
Like,